Good day, we are Group 4 and we are here to present our final project for ECE 135P-3 titled Smart Home Application. A smart home is a connection of different electronics and electric appliances inside a home and is controlled in a central unit that serves as the control system. Central units can be a computer, a phone, or a tablet. A few examples that a smart home can do are temperature and lighting control. Smart homes are found to be a convenient setup as most appliances can be maneuvered through internet access automatically or by a remote control, and the settings can be altered as preferred by the homeowner. Although a smart home can be convenient and cost-saving, it is still prone to malfunctions such as bugs and errors in the system.
For the objectives of our project, we aim to design 3 different inputs and 3 different outputs. Me and my group mates as researchers, we opt to build a smart home Arduino-based system to accomplish this task. Due to lack of materials in the allocated simulation tool Tinkercad, we will be using 3 different outputs to signify the different variables in a smart home Arduino-based system. For the first output is the automatic night door lamp, and the second output is the automatic door, and the third and last output is the heater and air conditioner control.
Shown in the table are the list of components used in creating the smart home system. The Arduino Uno R3 is used for the base of the whole system, and the red LED is used as one of the output for the heating controls to signify a high temperature or a heater. But since there is a lack of simulation tool for a heater, a red LED is used instead. And it's the same for the blue LED. It is used also as an output for the heating controls to indicate a low temperature or an air conditioner. On the other hand, the input for the heating controls is the TMP36 or the temperature sensor, which is used to identify the status of the temperature inside the house and to be able to output the right tool to use in the detected status of temperature. The ultrasonic distance sensor is used as the input for the door system, which is to determine the distance between the person and the door. And when the person reaches a specific distance, the output, which is in the form of a buzzer, will be triggered that represents the unlocking of the door. The photoresistor is used as an input for the outdoor lighting to determine if the surrounding is either bright or dark. That will lead to an output of turning on a light bulb.
The TMP36 is a precision centigrade temperature sensor that runs on low voltage. It is an electronic device that measures the temperature of its environment and converts the input data into electronic data to record, monitor, or signal temperature changes. It provides a voltage output that is proportional to a temperature in Celsius. The sensor can measure a wide temperature range, ranging from negative 50 degrees Celsius to 125 degrees Celsius. It's fairly accurate and is low cost, making it a popular choice for a temperature sensor.
An ultrasonic sensor that we used is the HC-SR04. This type of sensor is an electronic device that measures the distance of a target object, which for this case is the human body, by emitting ultrasonic sound waves and will convert from sound into an electrical signal so that the microcontroller will understand the signal that will be transmitted to it. For the pins which this type of sensor such as VCC, trig, echo, and ground. The VCC is the supply of this sensor, which is supplied by 5 volts from an Arduino. The trig is the trigger pin of this sensor, which represents it as an input, and it is the transmitter that sends a signal to a set of range. The echo is the echo pin, which represents as an output, and it receives a reflected signal coming from the object.
A photoresistor is made of high-resistance semiconductor such as silicon or germanium. This is also made of other materials such as cadmium sulfide or cadmium selenide. It is a light-sensitive component commonly used to show the presence or absence of light or to determine the strength of light. Since the decrease in electric current results to an increase in resistance, the resistance of the photoresistor increases when there is a decrease in the applied intensity of light and vice versa. This only means that, in the absence of light, the photoresistor acts as high resistance material. Its resistance can often be up to 1 megaohms, whereas in the presence of light, its resistance drops significantly, even down to a few ohms depending on the light intensity. The general assets of this component are being inexpensive and small in size. It is usually applied in street lights, solar street lamps, night lights, and clock radios.
Shown in the figure 1-1 is the Arduino wiring diagram of the automatic outdoor light. With the use of the listed components, the team designed the first feature of the smart home system. In the figure 1-2, the team associated the light detecting resistor to the analog pin 0. In line 3, the variable bulb was set into the digital pin 2. The LDR value was defined as an integer to be used later on the void loop part. Shown in the figure 1-3, the light detecting resistor was used as an input and the light bulb as an output. With the use of the serial monitor, the team was able to estimate the value of 500 to be set as the numerical equivalent of darkness. In the figure 1-4, the if-else statement was constructed to determine if the input was numerically dark enough to turn on the light bulb through the relay. The discussed implementation process ensures that the outdoor light will automatically be turned on during nighttime and off during daytime.
So this is the coding part of the heater and the air conditioner. As you can see, the temperature set for the heater is 87 in Fahrenheit. This indicates the reference level of hotness, while 75 in Fahrenheit for the air conditioner as an indication of coldness. For the setup, the VO terminal of the sensor is in pin A4. The blue LED is in pin 10 and the red LED is in pin 9. The value of voltage from the temperature sensor is converted in Celsius, then to Fahrenheit, if you want the value of temperature in Fahrenheit. Same thing applied if you want to convert it only in Celsius. If the temperature in Fahrenheit is below the reference level of coldness, which is less than 75, then the blue LED indicates that the air conditioner is operating. Otherwise, the heater is in use as the red LED turns on. So I will try to run the program, and I'm gonna activate the air conditioner by decreasing the temperature. Then the blue LED should turn on. Then I'm gonna activate the heater by increasing the temperature. Then the red LED should turn on.
This is the coding part for the door access control. Looking into the code, first is the initialization of the trigger and echo pins for the ultrasonic sensor, and then the initialization of the buzzer pin. The trigger pin is connected to pin 4, the echo pin is connected to pin 5, and the buzzer pin is connected to pin 7 of the Arduino Uno. Then, the time and the distance are initialized for the system to calculate the distance. For the setup function, the trigger pin is considered as the output because it will transmit an ultrasonic wave through the pin. For the echo pin, this will be the input and it is the receiver of the ultrasonic wave. For the loop function, we have set the trigger high for 10 microseconds to send an ultrasonic wave from the trigger, since the echo will tell us the distance traveled in microseconds. So for the equation, to calculate the distance, we converted the speed of sound into centimeters per microseconds to calculate the distance, and we divide the equation by 2 because we only require the distance it takes to hit the object and not the distance it takes to hit the object and come back. For the loop condition, we made the condition that if the distance value is less than or equals 320, then the buzzer will start to beep. Else, if the distance value is greater than 320, then the buzzer will remain quiet. Now, we will start the simulation to know how it works. We will treat this green circle as the object, and if it is outside this range, the buzzer will not beep, and if it is inside the range,
The figure shows the smart home system circuit. To simulate the said system, you can visit the link below.
And that concludes our presentation. We hope this video finds you well and have a good day.